So you'll see this link in today's agenda to the slides about unit 2 and 3, and there's a slide at the bottom which has a data types matching game. So just to make class a little interactive with a fun game, I'll be asking for some volunteers to help us get through this game. Basically, the way this game works is that on the left, we have a column of objects. And each object has its own data type. And we know already we can inspect and ask, well, what data type is a given object if we pass that object into what function? Quick recap. What function will tell us what data type some object is? We'll pass that object into this function and we'll see what data type is that object. Python built-in function for detecting data types. Yeah, type. And so we'll work more with the type function very commonly. If we're confused, well, what data type is this variable we're working with? We'll pass it into the type function. We'll do a little bit more of this in a few minutes. And so the thinking is here, if we were to pass each of these objects or variables into the type function, what would we see as a result? In other words, what data type is each object? So the way I'd like to do this is I'd like to invite volunteers who haven't yet received a Python sticker. So you're eligible for some Python stickers here. If we don't get enough takers from people who haven't yet gotten a sticker, then we'll open it up to other volunteers. I just want to spread the sticker love a little bit. All right, so does anyone have any questions about our goals for this exercise? All right, so I'd like to start with A. From someone who doesn't have a sticker yet, what data type is A?
It's a string.
String, yeah, why?
It's in quotes.
It's in quotes. We see quotes on the extremities, and that tells us everything inside is some kind of message. At the end of class, you grab a sticker. I'll have these stickers up here for you folks at the end of class. Awesome. So let me just take some annotation notes here, and then I'll share this after class. So here we have a string. Why? Because it has quotes on the extremities. Whether those quotes are double quotes like we see here, or whether it's a single quote, that's all good too. I recommend we use double quotes because that allows us to use like conjunctions and single quotes on the inside without any quoting level issues. Anyway, string, nice. All right, let's go to the next one. B. Boolean, exactly. How do you know or why? Right, we only have two Boolean values. One is true, one is false, and they're the opposite of each other. Awesome. C, probably the hardest one here, but if we have any brave volunteers, what data type is C? We can open this up to anyone. Tricky one here. None. Is this a Boolean? No, something else? None is like a null value or absence of a value. We won't work with it too much, but you might see it. And so the data type here is technically none type. The only instance of the none type data type is none with a capital N. None type. And so anyone who's familiar with like an NA value in Excel, that's kind of what we're dealing with here. A null value in SQL. And so if we need to represent absence of a value, we could use none. So that's a tricky one. Okay, let's keep it moving. Maybe there's some easier ones here. D, I love a volunteer. It is a string. Why? Yeah. Even, I guess we can have some numbers inside our quotes. It's still a string. And you weren't fooled by that. Nice. We also have a $sign here, which is not a number. So that's an indication that this is a string. But quotes on the extremities is what tells us here. All right, here we go. E, I love a volunteer. We talked about this data type very briefly, and we're going to focus on it some more today. And so I love a volunteer. A list, right? A list. Why do we know this is a list? Yeah, we see on the extremities square brackets. That's one way of knowing this is a list, but what's the other thing that tells us this is a list? Comma separated items, exactly. So with a list, it starts and ends with square brackets, and it's just some comma separated container of items. We can have a list of numbers, a list of strings, a list of booleans. We can even have a list of lists and start nesting them, and a list of dictionaries. And so, but at the top level, this is a list because we have square brackets and comma separated. And so you may have used a list already in your rock, paper, scissors to model the choices, the valid choices, rock, comma, paper, comma, scissors. We know that a list data type is one that we can pass into the random choice function, and it will give us one of these items in the list at random. So you might have already started working with a list, but we'll work with it a lot more this week. Okay, cool. Let's keep it moving. F. Integer, right, exactly. Why? Exactly. There's no decimal component. It's a number, integer. Cool. All right, here we go. Yeah, G. All right. Dictionary, yes. Why? How do we know? Yeah, what you're referring to is what we call key value pairs. And so this is an important terminology for us to talk about when we're talking about dictionaries. A dictionary contains key value pairs. Like a list, a dictionary can contain items. So this dictionary contains the string my book and the string silver. Unlike a list, where those items just have a numeric position about them, the first item, the second item, the third item. A dictionary has a textual attribute name for these items. So the name of the my book value is title. I guess title is the attribute name or key for the corresponding value of my book. So we see here's a key value pair. Title is my book. Now a comma separates the key value pairs. And we have another key value pair. The color attribute is how we're referencing the name here of the silver variable, the silver value. So with dictionaries, they start with a curly brace on the extremities. They have key value pairs. Each key is separated from its corresponding value by a colon. Each key value pair is separated from others by a comma. So it's like we still have a comma separated set of items. It's just that they have some kind of attribute name that we could refer to them by. And so the reason, or what might help you think about dictionaries, is if you look up some definition of a term in like a dictionary in a book or like a dictionary, we'll ask for the word. And so we'll know what the word is and we'll look up the corresponding definition for a given word. And so that might help you remember this is a dictionary. For each kind of key, there's some kind of corresponding value. For each word, there's a corresponding definition given my example analogy with the dictionary. Okay, we'll work with dictionaries more in a few minutes. So let's keep it moving here. H. Yeah. Here we are dealing with a list. Whenever we're asking what data type something is, we start on the extremities, the very outermost level. We could have some nested data types, and that is the case with this one, H. We have a list data type, and that's right. Unlike E, where we have a list of numbers, here we have a list of dictionaries, and that's all good. Nice. This is a list. How many items are in this list? Follow-up for anyone? 2. The first item is this dictionary. The second item is this dictionary. Yeah, question, go for it.
Yeah, I'm just like wondering what's the like difference between using H versus G, like what, because they're sort of this, obviously they're different, but like what would be the benefit of this one?
With H, we have a single object. So you can think of it like a single book, represented by these key value pairs or attributes and their names. With H, we have a list of those objects. So we have like many of them and they're related somehow. So I guess this is just a contrived example, but here we have 2 dictionaries that are kind of related to each other in some way. And so we package them up in a single variable called the list. This is a contrived example. We'll get into some more specific real life examples of modeling data using combinations. Does that answer your question or follow up? Feel free to ask follow up. All right, cool. Yep. So this is a list. Awesome. List of dictionaries. All good. All right.
Float.
Float. Why?
Half a decimal.
Exactly. Even if that decimal is 0, the presence of the decimal component makes this number a float as opposed to the integer that we saw before. All right, here we go. Last one. J. Exactly. This is a dictionary. Why? How do we know? Exactly. Here on the extremities, we have squiggly braces, and we also have key value pairs. Follow up for you. What is the key or what are the keys of this dictionary, J? Say that again. Yeah. So we know that a dictionary has key value pairs, one or more key value pairs. And so what is the key or one or more keys potentially for J? Yeah, numbers is the only key in this dictionary, and its corresponding value is what data type? Follow up for you? Exactly. So we can have a list in a dictionary, we can have nested objects, and that's commonly when we fetch data from the internet, whether it be getting data from Spotify or sports data or stocks data or whatever, we'll generally be working with nested objects, and we'll have to work our way through from the top level down into the nested structure. But at the top level, this is a dictionary. We see those squigglies, we see that key value pair. Awesome. Nice job, everyone. So again, for those of you who volunteered who don't have a sticker yet, feel free to grab one from the front of the room before we leave class or as on your way out. I'm going to take a screenshot of these answers and post this to Slack after class. Awesome. That was a